Hello, my name is Charukesh Panjala. Today, I want to show you my project about teaching a computer to spot weapons like guns and knives from the CCTV pictures. This is important because it will help keep places like schools, airports, and train stations safer by alerting people if it sees a weapon. So, right now, people have to watch a lot of CCTV cameras, which is boring, and also many people easily miss something. So, if a computer can help us by watching all the cameras at once and warn us quickly if it sees any danger. Now, even though there are many systems, the big problem is that some of the weapons can be tiny or hidden, and CCTV footage might be dark or blurry, and sometimes the computer might think a phone or tool as a weapon by mistake. And our solution for this is using the YOLO to solve this. So, YOLO stands for you only look once. So, it is a computer program or AI model which is great at finding objects in pictures. YOLO is smart and very fast. And these are the research questions which we are going to view in this project. And to teach the computer, we need lots of pictures. So, I have used this data set from Kaggle, which is called Guns and Knives Detection in CCTV Videos. It has thousands of CCTV images all labeled so that we know if there's a gun or a knife and where it is. So the data is split into three parts: training set, validation set, and test set. So this code is like to check out some sample images and the length of the data, that is the number of images present in each folder. So these are the sample images. As you can see what the computer will be able to see. Now I'm going to tell how I taught the computer. So first I have installed the Ultralytics package. I have imported YOLO from it, and I've used the YOLO V12 model, which is the latest model. So after that, let's start the training. So here can see that I have used 15 epochs, means it will be trained for 15 rounds over and over, and each time the model will try to get a better findings out of the weapons. So it took a quite long time for the training. Uh, so after the training, now I'm going to talk about the evaluation results. So these are all the results, and I'm going to explain briefly about each thing. So if you can see this is the first thing. So this big chart is how the model learns over time. If you can see, at first the model makes a lot of mistakes, but as it learns, those mistakes grow down. Precision, recall, and MAP all go up as the model gets better. And the highest precision it reached is 0.71, recall is 0.66, and MAP stands at 0.716. Now the F1 score curve. This is the F1 confidence curve. This shows how well the model balances finding weapons and not making false alarm. The higher the F1 means the better the balance. And the next one is the precision recall curve. This is one of the most important graphs. It shows the model is really good at finding knives because the MAP is at 0.83, and it is a bit less for the pistols, and MAP is 0.7, 0.6. And the next one is the precision confidence curve. So in here we can see that as the confidence increases, the precision goes up, but recall goes down. It means that if you want fewer mistakes, it may also miss more real weapons. This is always a trade-off. And next one is the recall confidence curve. You can see here that the yellow line is the knife and blue one is pistol, and this is the average. And after that, this is the confusion matrix. This is like a report card. You can see, if you want to make fewer mistakes, we may also miss more real weapons. It is always a trade-off. So I think our model is trained better for knives and a little less for pistols. And this is our confusion matrix normalized, means like this is between 0 to 1. You can see that for knife it is 86%, which is highest, and for pistol it is 56, and most mistakes are done with pistols. After seeing the results, we can say that the model is trained more for knives and a little less for the pistols. So now I want to predict some new images using my model. So I have used the images from the test folder from my dataset. So I have picked up 20 random images from this. Then I use my model to predict them, and I'm going to cover three correct and three incorrect models. So in this first picture, we can see that our model has successfully found out the pistol, and in the second picture, it has flagged the knife, and in the third picture, you can see the model found two guns in the picture, and the three incorrect predictions are as follows. So in this picture, you can see the model missed the gun because it is like partly hidden or it is very small, and the main reason might be that it is at a specific angle and is being blocked by other items beside it. And if you see this one, in this one you can see the man carrying the gun, but our model missed that one. Maybe it's because the rifle is behind the door and it is a strange angle. Maybe that might be the reason the model has missed it. And this picture, if you can see, the model had missed this one because it is a little unclear and blurry, and the gun is like so far away for the model to catch it. Also, the gun is in an angle that it might be confused for a mobile or something. So I think that might be the reason the model had missed this one. And now, after training the model, uh, I have these five important questions to really understand and how a model did this way. First question is like effect of training epochs on detection accuracy. So in this training, I have trained my model with three type of epochs. So one is for 5, second one is 10, and then 15. So after training these three, it took a really quite long time to train for these three epochs. So after that, these are the results that I got after my training. So for so what happened is like, especially for the first 10 rounds, the improvement is slow. So after the 5 box training, the training for the 10th round, there was a drastic improvement. But after that, the improvement is slow, and you can see the conclusion for this. So even if we train a large number of epochs, I guess the model will not be that efficient. And our second research question is the effect of input image size on detection and accuracy. So we have the code. We are predicting the model with different type of image sizes, which is 320, 640, and 960. So after the prediction, we have got this result. So we can see that using large number of images didn't improve the accuracy, but it made the model a little bit slower. Smaller images work just as well and are faster. And third research question is that the comparison between the YOLO V12 versus YOLO V8 performance. So after predicting the results using the two models, we've got this result you can see that both models are similar, but YOLO V12 is a little more accurate for the comparison dataset. Mm, and the next one is the model robustness of different lighting conditions. So here we pick three type of images. So image which is a little brighter, one is darker, and another one is has a shadow. So after predicting that one, we got the result. So the model works best in bright and clear images. It struggles a little bit for the dark image or shadow conditions, and it sometimes misses the weapon for that one. And the fifth risk question is the effect of confidence threshold on false positives and false negatives. So after this, so we have used the three thresholds 0.10, 0.25, and 0.50. After that, we have run the prediction for three type of thresholds. Then we have saved the results, and this is the result which we have got. So we can see that lower confidence threshold finds more weapons, but it also has more mistakes. But as the thresholds go higher, it will avoid false alarms, but it missed real weapons too. So for safety, I think it is better to use a lower threshold so we don't miss any threats. So I think to make my model a little better, we need to add more different images and use a little tricks to make dark or blurry pictures more clear before we check for weapons, and also test on even more challenging scenes like a darker data set or on blurry images, and so on. Thank you all for watching.